بسم الله الرحمن الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضيات لغات، السلام عليكم ورحمة الله وبركاته. اليوم سنتناول درس جديد في مادة الاستاتيكا بعنوان تابع الازدواج. طبعا احنا عارفين الازدواج، علم الازدواج اللي هو القابل very important lesson in our life. Welcome my dear student in our math program for secondary 3. Today we are taking new lesson in static subject. Its title following a couple. My dear student, what is the meaning of the couple? What is the type of the couple? How to use couple to find the unknown forces? My dear student, we know that a couple, two forces equal in magnitude, opposite direction, the action of line don't lie on same straight line. And we know that the couple has positive or negative. Positive when the direction with anti-clockwise, negative when direction with clockwise. But the couple is moment of the couple equals the product of the force and the distance between the two forces. My dear student, look at following a couple or examples about following a couple. Look at, my dear student, following a couple. Example: A, B, C, D fine lamina in the form of rectangle in which AB equals 18 centimeter, BC 24 centimeter, and of weight 20 Newton, acting at intersection of its diagonals. The lamina is suspended by a thin horizontal pin passing through small hole near the vertex D, so that its plane is vertical. If a couple, the magnitude of its moment is 150 Newton centimeter and its direction perpendicular to the plane of lamina and acts on the lamina. Find inclination of BD to the vertical in position of equilibrium. Solution. Look at, my dear student. We have ABCD is a fine lamina as shaped rectangle. Its weight 20 Newton, which act at midpoint of two diagonal. Remember, AC, BD, two diagonals of rectangle intersect at point O. We know that AC equals BD but not perpendicular. The lamina is suspended at point D. We have in the opposite figure represent a lamina suspended from D and the moment of couple, which its magnitude 150 Newton centimeter, perpendicular to the plane of lamina. Then we deduce that. Look at, my dear student, we have two forces. The first force is the weight of lamina, is 20. What is the second? Is R, reaction. Look at R equals 20. This represent is a couple. Therefore, R equals 20. The distance between the two forces R and 20 equals L. Find the value of L. To find the value of L, we put the moment of couple 150 Newton centimeter equivalent the moment of the two forces 20 and 20. Then we deduce that 150 equals 20 times L to find the value of L. If we find the value of L, it is easy to find inclination theta, which BD inclined with vertical wall. Look at, my dear student, lamina is in equilibrium under two couples. We say that the two forces 20 and R form a couple. Its moment equals 150 Newton centimeter. Then we deduce that the 150 moment of the couple equals 20 times OE. OE, distance between the two forces. Then L or OE equals, we find the length of OE sine theta times BD equals, we reduce that, sine theta equals 1 over 2, then theta equals 30 degrees. We now translate to another example. ABCD is a thin uniform lamina in the form of a square of side length 50 centimeter. Remember, this lamina is shaped square and its weight 300 gram weight acting at the center of each square. The lamina is suspended from horizontal pin passing through a small hole near the vertex A, such that its plane vertical a couple with magnitude of 7,500 gram weight centimeter acts on lamina in its plane. Remember, my dear student, after we suspended lamina as shaped square at near to A, we find a couple, its moment 7,500 gram weight centimeter acts on the lamina in its plane. Find inclination of diagonal AC to vertical in equilibrium position. Solution. Look at, my dear student. ABCD lamina as shaped square suspended at A. The lamina, its weight 300. We know that 300 and R which form a couple. This couple equals 300 times ME. We know that from the given there is equivalent couple AD, the length of square 50 centimeter, diagonal AC 50 root 2. This rule, if we have side length of square 50 centimeter, then the diagonal 50 root 2 centimeter. Diagonal equals side times root 2. AM equals half AC equal 25 root 2. In triangle AME, we know that ME over MA sine theta. Therefore, ME 25 root 2 sine theta. Then we deduce that sum of couples moment equals 0. We have two couples. Negative F times L, F in this case 300. We reduce 300 times ME 7,500, therefore divided by 300 ME, therefore 25 sine theta 1 over root 2 or root 2 over 2 equal 45. Theta, measure angle theta equals 45 or 135. Why? Because the side with positive maybe lies in the first quad or in second quadrant. 45 or 135. Maybe lies in the first, maybe lies in the second quadrant. The first quadrant, theta equal 45 degrees. Second quadrant equals 135 degrees. Another example. ABC is a lamina in the form of equilateral triangle. Its weight is 50 gram weight. Acting at the point of intersection of its medians. The lamina is suspended by a thin horizontally pin passing through a small hole near the vertex A, so that its plane is vertical, a couple whose direction is perpendicular to the plane of the lamina, and the magnitude of its moment is 250 gram weight centimeter acts on it. If the lamina is in equilibrium, find inclination of AB to horizontal, given that the height of triangle is 15 centimeter. Solution. My dear student, we find before that, or we represent lamina as shaped rectangle and square. In this case, we represent lamina as shaped equilateral triangle. We know that equilateral triangle, 3 sides equal in length, 3 angles equal in measure, measure of each angle equals 60 degrees, and the median is perpendicular from A to BC, and the point O divides the median as ratio 2 to 1 from the vertex or 1 to 2 from the base. The lamina is in equilibrium under effect of 2 forces. Look at weight of downward 50 gram and the couple from given. Reaction R equals the weight 50. Look at 2 forces form a couple. The first 50 times 10, 50 times 10, 10 the distance between times sine, therefore sine theta plus 30, 250. Therefore, we deduce that ratio between AO and AD to third. Why? This median. AD is a median. AO to third. From given AD equal 15, we deduce that AO equal what? Equals 10 centimeter. Look at in triangle AOX. We know that sine theta plus 30 equals 1 over 2. Why? XO is 5, AO 10. Therefore, sine theta plus 30 equals what? 1 over 2. Maybe equals 30, maybe 150. Then we deduce that theta equals 150 minus 30 equals 120 degrees, or theta plus 30 equals 30. Then in this case, theta equals 0 degrees. We deduce the AB line inclined by 30 or 90 degrees with the horizontal. Why? Because if theta equals 0, then with horizontal equal 90 or 30 degrees. Another example. A rod of length 40 centimeter and its weight 2.4 kilogram weight acting at its midpoint can rotate easily in vertical plane about fixed hang at end. Remember, my dear student, we have a rod. Its length 40 centimeter and its weight 2.4 act at midpoint. But we know that the rod can rotate easily in vertical plane about fixed hang. A couple of magnitude 24 kilogram weight centimeter and whose direction perpendicular to vertical plane in which the rod can rotate. Acts on the rod. What is required? Find the magnitude and direction of reaction of the hang. Magnitude and direction of reaction of the hang and inclination of the rod to vertical in position of equilibrium. Solution. Look at, my dear student, the first figure in the left represent AB is a rod, the weight 204, the distance 24, the distance between the rod and the wall which hang represent on it or subtended on it equals L. We know that sine theta equals L over 20. AB, the length of AB equals 40, then the sine theta equal L over 20, therefore L equals 20 times sine theta. My dear student, we know that R equal 2.4 kilogram. The weight of the rod 2.4 kilogram. Then by using 24 equal F times L, then we deduce sine theta equal 1 over 2, measure theta equal 30 or 150. Another example. AB is a rod of length 6 centimeter and of weight 18 Newton. Acting at its midpoint can rotate easily in a vertical plane about horizontal bend passing through hole in the rod at the point C 15 centimeter from A. If the rod rests with its end B on a smooth horizontal table and the end A is pulled with a rope horizontally until the reaction of the table B equals to weight of the rod. What is required? Find the tension in the rope and reaction of bend given that the rod in equilibrium in position in which it is inclined at angle of measure 62 horizontal. Also find the magnitude of and the direction of reaction of the bend. Solution. My dear student, this example very important. Why? Because has many required to find it. Look at the rod AB, its weight 18, which table in smooth. What is the meaning table is smooth? Which AB, the one end of it, of the rod on the table, means reaction is perpendicular to the table. R1 perpendicular to the table is vertically upward. Then we deduce that R1 equals 18 as two forces equal in magnitude form couple. The two forces 18 and 18 distant between them L form couple. What is the moment? The moment negative 18 times L1. We know that the rod AB 30 centimeter, the midpoint, which weight act at midpoint, then the L1 equals 15 sine theta. 30 cosine 60, the inclination angle equals negative 270 Newton centimeter. The rod is in equilibrium under couple M1 and two forces T and R2. Look at the tension of the rod T. R2 is reaction, form a couple. The distance between them is perpendicular to action of the line. T and R2 form couple. Its moment 270 with positive direction. R2 equals T, form couple, equal in magnitude, opposite direction. Then T times L equals 270. In this case, L equal 15 sine 60. Then tension equal 12 root 3 Newton. Another example. ABC is a triangle, right angle triangle at A, in which AB equals AC equal 5 centimeter. Forces of magnitudes 40 and 40 and 42 gram weight act along BA ray, AC ray, CB ray, respectively. Find the two forces acting at the 2 points B and C perpendicular to BC for the system to be in equilibrium. Solution. Look at, my dear student, ABC, right angle triangle at A. Isosceles AB equal 5, AC equal 5. Then we deduce that BC 5 root 2. Two forces act at C and at B form couple. The forces act in same cyclic order. AB, BA, 40 act at BA. Another 40 acts at AC. The third force, 40 root 2, acts at CB. Look at BA, AC, CB is cyclic order. When divided, the force among side of triangle constant ratio 40 over 5, 8. 40 over 5, 8. 40 root 2 over 5 root 2 equals 8. What you mean? Excellent student. This form couple. What is the moment of this couple? Equals K times twice area of triangle. What is the area of triangle? It is easy to find. Half base times height. Half 5 times 5 equal 12.5 centimeter squared. The ratio equals 8 times twice to find the moment of the couple. Then we deduce that the ratio between the 40 over 5, 40 over 5, 40 root 2 over 5 root 2 constant ratio equals 8. This is constant K. Then these forces form a couple with magnitude or its area, its moment 8 or K times twice area of triangle. 8 times 2 area of triangle, 8 times 2 times half times 5 times 5. Remember, ABC, right angle triangle at A. Area half base times height. Then, my dear student, the moment 200 gram weight centimeter. How to find the force F? We know that is in equilibrium. This in equilibrium, the two couples, summation of two couples must be equal 0. Then we deduce that 200 moment of the couple equals the force F multiply 5 root 2. What is the 5 root 2 distance between the two forces? Therefore, F equals 20 root 2 gram weight. This is the magnitude of the force F. My dear student, by the end of the lesson, we know that the couple, very important lesson, we can form a couple by using forces along the three sides of triangle or square or rectangle or trapezium, but in special case, if three forces which act along three sides of the triangle in cyclic order, then the moment of the couple equals K, or the constant multiply twice area of triangle. My dear student, I am very happy to spend such time with you. Thank you. Goodbye.